Okay guys, Assalamualaikum. This is our last part for AC meter section. So where we left off basically we left off with this example lah yang saya tak sempat nak cover. Okay, so in this first example for a full wave rectifier circuit. Okay, so the question asks you to compute the value of the series multiplier resistor. Okay, which is this resistor here. Okay. For a 10 volt RMS AC range of the voltmeter. So it's given that the input of this AC meter is an AC voltage with RMS value of 10 volt. Okay. So given that the internal meter resistor is 500 ohm and the full scale deflection current is 1 milliamp. So this is the meter. This is the PMMC meter. Okay. So how to solve this? So we can use this formula. Okay, so remember that let's say we use the method, the DC sensitivity method. So the formula for DC sensitivity SDC is 1 over the full scale current, which is 1 over 1 milliamp. So the 1 milliamp here is basically the DC current, okay, going through this meter. So and it's equal to 1 kilo ohm per volt. And then we can calculate the AC sensitivity. Okay, its AC sensitivity is 0.9 multiplied by the DC sensitivity. So this is for only for full wave rectifier. So 0.9 multiplied by 1 kilo ohm per volt, and you get around 900 ohm per volt. Therefore, the multiplier resistor is, the formula is Rs equals to SAC, the AC sensitivity, which is this value here, multiplied by the range, okay, which is the RMS value, minus the internal voltage. So 900 multiplied by 10 and minus 500 have 8.5 kilo ohm. So 8.5 kilo ohm is the RS value here. This is 8.5 kilo ohm. Okay. So note that voltmeter using half wave and full wave rectifier equation are suitable for measuring only sinusoidal AC voltages. Okay. Let's take a look at another example. Okay, sorry for the blurry font. So an AC voltmeter uses a full wave bridge rectifier and the basic meter with full scale deflection current of 2 milliamp and the meter resistance, internal resistance of 500 ohm. Calculate the multiplier resistance for a 10 volt RMS range of the voltmeter. This is basically almost the same question that we just saw just now. Okay, so the meter, since the meter uses full wave rectifier, we can use this equation here. We know that the VDC is 0.9 multiplied by VRMS. So the multiplier resistor is E voltage E. See, E and E is the same thing. Okay, multiplied by IDC minus the internal resistance, which is EDC. We know is 0.9 RMS divided by IDC minus RM. Then if we crunch in the number, we got the multiplier resistor is around 4 kilo ohm. Okay. And then this next example, okay, so also the question asks you to calculate what is the multiplier resistor for a 50. Now we have a different value of RMS voltage. This is 50 volt, okay, and a different say this is RS. This is not 10k yet because you want to calculate the 10k. Okay, so let's say this is unknown yet. Okay, this is what you want to calculate. Okay, so the full scale deflection current is given 100 microamp and the internal meter is given 100 ohm. Okay, so can use this method. For example, to calculate the DC sensitivity is 1 over the full scale deflection current, and you have 10 kilo ohm per volt. Okay, the step 2, calculate the AC sensitivity. That's by using this formula. SAC is 0.9, SDC is 9 kilo ohm per volt. And then the multiplier resistance is given by Rs is SAC multiplied by the range, which is the RMS voltage, RMS voltage minus 100. Okay. And then finally we got, if we crunch in the number, we have the multiplier resistance should be equal to around 450 kilo ohms. Okay, so I think this is among our last few example. So again, this question to calculate what is the multiplier resistance. Okay, so this is a 10 volt RMS value, all right, and 1 milliamp full displacement current, and for a different internal resistance. So following the same formulation, I believe is pretty much easy to follow. Yeah, I think it's used also the same step as before. So we can go ahead and check yourself, this example. Okay, so before I end up this video and before we end up this AC meter, so let us summarize. These are the table to show you the difference. Okay, for both. Okay, let's take a look at one by one. So for the voltage peak to peak, or EP to P, for half rectifier, okay, sorry about that. For half rectifier and full rectifier, the formula is the same. It's 2 times the RMS voltage multiplied by 1.414. Okay, so that's the peak to peak voltage for the rectifier. So the max or the peak voltage is VRMS multiplied by square root of 2, which is same as the full rectifier. Okay. However, the average value, or I can say the DC value for half rectifier is 0.318 multiplied by the peak to peak voltage. Okay. But whereas for full rectifier is 0.636 multiplied by the peak to peak voltage. You can also relate this to RMS voltage by including changing this into putting this into here to relate between RMS voltage. Okay. So the sensitivity, AC sensitivity for half rectifier is 0.5 multiplied by SDC, whereas for full rectifier is 0.9 multiplied by DC sensitivity. And finally, to calculate the multiplier resistance, okay, this is multiplier resistance. Okay, so it's RS equals to sensitivity multiplied by 0.45 multiplied by the voltage, RMS voltage minus RM, whereas for the full rectifier is the sensitivity multiplied by 0.9 multiplied by VRMS minus the internal resistance. Okay, so pretty much I think we have almost finished, except I think I want to introduce you with a few type of meter movement. Okay, so far we have learned about the Assenval or PMMC meter movement. We know that in order to PMMC is very good in measuring DC meter, DC voltmeter, ammeter, and so. But if you want to measure AC voltages, you need to convert it into to attach a rectifier circuit. So, but there are other type of meter movement. For example, this one is called electrodynamometer. Okay. So basically, I don't want to deliberate this too much, but I think it's enough for you to know that there is this called electrodynamometer, which is basically it is arranged in such a way that they have two fixed coil and one moving coil. It's a fixed coil and one moving coil, and then this meter basically can measure AC meter directly. We don't need to have any rectifier circuit in order to convert it into AC, because due to some interaction of magnetic field between fixed coil and moving coil, basically the greater the voltage here, basically the meter here will move only in one direction. Okay, all right. So I just assume that, just for now we accept that that is the principle lah. Okay, so if you want to learn more about the principle, you can go maybe later on if you have some time. So basically that is how this electrodynamometer works. So as okay, I can explain this, but I think we can just skip this part. Okay, there's also another type of meter movement which is called iron vein movement. So vein movement is like basically you have a two vein. Vein is like a slab of material, a metal that is there's a coil wrapped around these two vein. Okay, and then it can also measure directly AC voltage. Okay, so the moving iron vein operates between the magnetic repulsion between light poles. Okay, I don't want to elaborate so much. I think just enough for you to know that this iron vein meter exists, and it can be used to measure directly AC voltages and current. Okay, this is all the explanation, but I think I'm gonna skip this part. So now we can towards the end of chapter 2. So we're going to stop here, and then we're going to continue with our next chapter, which is on oscilloscope. I'll see you in next class. Okay, Assalamualaikum. Thank you very much.